Hello friends, welcome to my channel. Today I am going to control the speed of this DC motor based on PWM method, and you can see the speed is going to be displayed on the LCD. But you will face one problem in this project, and that problem is you can see the LCD is not updating itself. Although I have rotated the knob of the potentiometer at its full limit, but the LCD is not updating. So I will give you the solution of this problem in this video. So let's start. Now let us quickly look at the circuit connections and one very important mistake that you need to avoid in any of the project in order to get it work. So let's start with this potentiometer. So potentiometer has three terminals, left one, the middle one and the right one. So the middle one is connected to the analog pin on the Arduino, and you can connect any of the extreme pins to the power pins. Like if you connect this to ground, then the right one should be connected to VCC, or if you connect this one to VCC, then this should be connected to the ground. Now coming on to this LCD display, so I have already talked about the detailed working of this LCD display in my previous video. You can check out the link in the description. So this LCD display can be connected in two ways with the Arduino. The first one is without this I2C module. So if you don't want to use this I2C module, you need to connect this many number of wires with the Arduino, right, which are large in number. So to get rid of all these wires, we connect this I2C display at the back of it. So this I2C display converts the working of all these wires into just 4 wires. Right, so let me show you the pinout of this display. The first one is the ground pin, the second one is the VCC, the third one is SDA, which stands for serial data, and this SDA is connected to pin number A4 of the Arduino, and the fourth one is SCL, which stands for serial clock, and this is connected to pin number A5. Okay, and this I2C module uses a communication protocol which is called I2C or I2C. And if you want to use I2C communication protocol with Arduino Uno, then only two pins are there on the entire board, which are A4 and A5, right? So these two pins are reserved for I2C communication protocol. You cannot use any other pins. So this display is also using I2C communication protocol. That is why I am using A4 and A5. Now let us discuss about this L298 and motor driver. So these two pins are connected to the DC motor. This one is connected to the 12 volt input supply from the battery. This one is connected to the ground, and this is the 5 volt output. And this pin is connected to the PWM supported pin on the Arduino, and this is used to control the speed of the DC motor, right? You cannot connect it to any other normal digital pin, otherwise you won't be able to control the speed. And the next two pins are used to control the direction of the motor. Suppose if this pin is controlling the anti-clockwise direction, then this one should be controlling clockwise direction, and vice versa. Okay, and you can connect these two pins to normal digital pins. Now let me discuss that one mistake that you can make in any of the electronics project, and that mistake is a common grounding problem. So obviously I am going to power this motor driver from the battery supply, and right now I am powering the Arduino from the 5 volt and the ground pins of the motor driver. But suppose instead of powering from the motor driver, you want to power the Arduino from the laptop. Okay, so there will be two power sources in this project. The first one is this battery, which will power the motor driver, and one is a laptop or any other computer which will power this Arduino. So there must be a common ground between the battery and the laptop, otherwise your project won't work properly, right? So right now I'm taking out another jumper wire from the ground pin of the motor driver, which is this gray wire, and this is connected to the negative rail of the breadboard. And from the negative rail of the breadboard, I am taking out another jumper wire, which is this brown wire, and this connected to the ground of the Arduino. So in this way, there is a common ground established between the battery and the laptop. So you must ensure the common ground should be established among all the components of the project. Now first of all, I will discuss the problematic code which is creating the updation problem in the LCD, and then I will discuss the solution in this code itself. We are importing this library liquid crystal I2C.h. Now there is also one library which is simply liquid crystal.h, but actually we are using I2C module for the communication. That is why I am using this library liquid crystal I2C.h, and I am defining one instance of this library which is called LCD, and this 0x27 is the hex address of the LCD display. So basically whenever you connect any I2C device with the microcontroller, you need to define the hex address of it. So how did I find this hex address of the LCD display? I have already explained in my previous video. You can check out this iTip. And 16 means the LCD has 16 columns, and 2 means the LCD has 2 rows. Now this is the potentiometer pin A0, which is the analog pin, and this enable pin will be used for controlling the speed of the DC motor. And in1 is the direction 1 pin, and in2 is the direction 2 pin. These are used to control the direction of the DC motor. And in the setup function, I am defining this baud rate 9600 for the serial communication between the Arduino and the laptop. And all the speed controlling pin and the direction pin of the motor driver are defined with the output mode, and we are initializing the LCD display with this function .init, and we are turning on the backlight of LCD display, and we are turning on the motor in one direction, which is in one pin, and we are turning off the other direction. So high means turning on and low means turning off. And in the loop function, we are reading the analog state of this potentiometer pin, so it will output analog values, right? And that analog values is stored in this variable port value, and we are mapping this potentiometer value from this range to this range. So Arduino microcontroller can read maximum analog values up to 1023. Okay, so 0 is mapped to 0 and 1023 is mapped to 255, and all the middle values are mapped accordingly. And this is the speed percentage values. So we are mapping this value, potentiometer value, from this range to 0 to 100. It means 0% and 100%. And we are writing that speed, that means PWM value, on the enable pin for controlling the speed of the motor. And on the top row of the LCD display, we are displaying this text motor controller, and on the bottom row we are displaying the speed percentage of the motor. Now in this for loop, we are doing two processes. First of all, the changing of motor speed and the updation of LCD, both in the same loop, one after the other. But due to motor spinning, it also creates back EMF and signal noise, and because of that noise, it disturbs the I2C communication bus. Okay, so because of that, the LCD was not able to update itself properly, and for that I am defining one variable here, last LCD update is equal to 0. Now what we are doing in the loop function, we are updating the motor speed at the same rate as we were doing previously, but we will update the LCD this time only after 2 milliseconds have passed. So we are using that variable last LCD update. So millis gives you the time since the microcontroller started to run, and this is the difference between the current time and the last time. If it is greater than 200, then only we will update the LCD, otherwise not. So this prevents the LCD communication with the Arduino from stopping down or slowing down due to this loop function. Another improvement you can do is that by importing this wire library, which is used for I2C communication, and increase the speed of I2C communication using this function wire.setClock 400,000. So this will make the I2C communication 4 times faster. So I hope you have learned something new from this project, and subscribe to my channel and share this video. And still, if you have any doubt regarding this project, please ask your query in the comment section, and let us meet with a new project in another video. And thanks for watching this video.